So let's try this. Maximize f of x comma y equals y squared minus x cubed, subject to x squared over 4 plus y squared over 9 is equal to 1. So in this example, the g function is, we were supposed to have g is equal to a constant. So that constant is 1. So g of x comma y, we have to build to be x to the second over 4 plus y to the second over 9. So we'll compute a gradient. Sorry, I'm missing an angle bracket here. But the gradient of f is negative 3x squared comma 2y, and the gradient of g is x over 2 comma 2/9 y. And when we take the equation from Lagrange multipliers method, from this method, we'll get something that looks like this. So just the first vector equals lambda times the second vector. We can go ahead and apply the scalar multiplication of lambda to the vector on the right, and then set components equal. So we have negative 3x squared equals lambda times x over 2. We'll call that equation A. We have 2 times y for the second component equals the second component lambda times 2/9 times y. We'll call that equation B. We also earlier had the constraint at the very beginning. It was originally just x squared over 4 plus y squared over 9 equals 1. We'll call that equation C. Of these, my personal opinion is that B is probably going to be the easiest to work with. So what I thought I'd do just to try this is to subtract on both sides and then factor out 2y. So you have 2y times the quantity 1 minus lambda over 9 equals 0. And so from this, you can, we've got a product equaling 0, so we apply this thing from algebra, right, that each of the individual factors can equal 0. So 2y equals 0 leads to y equals 0. The other option is what's in parentheses equals 0, and that's going to lead to lambda equals 9. The word or is actually the correct word here. This is or as in like a typical logic class, and when you do the zero product property, even for like solving a quadratic equation, there should be the word or. So the point with this word or, though, is that either y equals 0 or lambda equals 9. That's going to create two different scenarios. We don't know which thing occurs, so let's just let's kind of run this through two cases or two scenarios. So either y equals 0 or lambda equals 9. We don't know which. Oh, by the way, here are just the equations that we started with for reference at the top, being called A, B, and C. So we'll take the two cases, right? Again, it was y is 0 or lambda is 9. So what if y is 0? Then what happens? Well, then the C equation has the term y squared over 9 drop out to be a 0. So then x squared over 4 equals 1 becomes, x squared equals 4, square root both sides, you get x equals plus or minus 2. So then there's two possible values of x as we see, right? X equals positive 2 or x equals negative 2. By the way, this is the word or again because it's x equals plus or minus 2. So we'll look at some subcases. Let's say x equals 2. Then go to equation A, and you're going to get lambda equals negative 12. So then we get this combination of values. X, y, lambda is 2, 0, negative 12. The other possibility was x equals negative 2. Then equation A is going to lead to lambda is equal to positive 12. So we get this combination of x, y, lambda being negative 2, comma 0, comma positive 12. Okay, so again, from y equals 0, the clue from equation C led to only one of two possible values for x. It was plus 2 or minus 2. Okay, and then let's step back and look at the other thing. Remember, we had learned that either y equals 0 or lambda is equal to 9. So what happens when lambda equals 9? I then chose to look at equation A instead. I don't have to be systematic about the order. But if, so lambda plug in 9, you get an equation that looks like this. It looks a little messy, but we can, add 3x squared to both sides and then factor out 3x. So you get 0 is equal to 3x times quantity x plus 3 halves. Zero product property applies here. So you're going to get 3x equals 0, which leads to x equals 0. Or you'll get x plus 3 halves equals 0, which leads to x equals negative 3 over 2. So here we get two values of x. And it is an or, so we'll split this up into two possibilities. So one possibility was x equals 0. So again, lambda equals 9 leads to only two possible values for x. Those values are 0 or negative 3 over 2. So we'll pursue this situation of when x equals 0 and see what happens. And from equation C, the first term drops out, so we'll get y equals plus or minus 3. So there are these two combos of xy lambda. It's 0, 3, 9 or 0, negative 3, 9. The other value of x that we need to pursue is x equals negative 3 over 2. Then if we look at equation C, it's a little messier, sure, but if we work through the algebra here, we're going to get y is equal to plus or minus 3 root 7 over 4. So we have an x, y lambda combo of negative 3 halves and y value 3 root 7 over 4 comma 9, or we have still x is negative 3 halves. Now the y value is the negative of what it was before, and lambda is still 9. So there's a lot of possibilities here, right? So we've got many possibilities of x, y, lambda. Count them up here. There's 1, 2, 3, 4, 5, and whoops, let's try that again. There's 1, 2, 3, 4, 5, and 6. So we'll take our 6 combinations of x, y, lambda, and we were asked about maximizing, recall, f of x comma y equals y squared minus x cubed. So here's one of our 6 xy lambda combos, and we don't really need the lambda. It was just part of the process that of the geometry of this. So we'll just look at the x and y values and then just compute f at 2, 0, get negative 8. Here's another one of the xy lambda combinations we had, and we'll compute f of negative 2, 0 is equal to positive 8. Another one was 0, 3, 9. We only need the 0 and the 3, so f of 0, 3 is 9. And then here's another one. F at that x and y value leads to 117 over 16, which, yeah, sorry to use a calculator here, 7.3-ish. And then at this other xy lambda combination, we also get the value 117 over 16. And so the maximum value of y squared minus x cubed occurs with the constraint. So with that constraint happens to be when the z value is equal to 9. That's the largest value of z. That occurs when xy is equal to 0, 3, or sorry, one of the rows is missing, but we should have also computed f of 0, negative 3, but that's also going to give you the number positive 9. Okay, so here's the funky thing about this process is in the end, when we're starting to look at z values, we only care about x and y. We don't really need lambda for that, but we had to compute lambda along the way in order to get the 6 ordered triples. The numerical value of lambda itself is never actually used. We just needed to evaluate the function f of x comma y. It seems strange, but it works. So lambda is just about, it's just really about the gradient of f and the gradient of g need to point in the same direction, and that's what lambda does. So yeah, what is the role of lambda? Consider several viewpoints: procedurally, geometrically, algebraically,